Good day, guys. My name is Prince Bernard, a student of education studying physics in LASU, Lagos State University. I'll be teaching elasticity in physics. Please like, comment, and hit the subscribe button, and stay tuned as you enjoy this class. Thank you. This particular topic, elasticity. A perfect rigid body is a body that's the distance between any point on it remain constant. But most materials are subjected to deformation. Effects of deformation can be seen as change in length, change in volume but no change in shape, change in shape but no change in volume. So let's talk about change in length. One perfect example we all can relate to it for change in length is a rubber band. A rubber band can be used to, when it gets to its plastic limit, it can't be returned back to its original form. So, and for the change in volume but no change in, sorry, I didn't really give a much explanation for the rubber band, but you can just try it at home. Get a rubber band. When you stretched it much, when you stretched it past its, elastic limit. This bead I'm holding is an example. There's a way I'll stretch this bead now. There's a way I'll stretch this bead. It will pass its elastic limit, and it can't go back to its original form when it passes its elastic limit. So you can just try it at home, get a rubber band and try it. So for the change in volume but no change in shape, change in volume but no change in shape, there are many examples we can use for that also, but between that you can also try some other examples in your house. So we have change in shape but no change in volume. Okay, an example for this, let's see a dough that they used for making bread, baking bread, and some other things that they bake. So a dough is a perfect example. When you get a dough, there's a stick they use in pressing it. It goes through some pressing, and I don't know what they do, but it goes through some pressing, and while doing that, it changes its shape, from different, because while you're pressing it, you can press it in different way from different direction. So with what you are doing, it can change the shape of that dough, but it doesn't change its size or its volume, because it's still the same volume. It still has the same volume, but just changes shape as it undergoes the pressing. So that would be all for that. And so moving on, for a body to undergo elasticity, it is a must that such body is acted upon by a force. So like the rubber band we spoke about, the force that is being placed on it, for this body, this is the body. For this body to undergo elasticity, my hand is the force that is being placed on it for it to undergo elasticity. So you can see this bead stretching. So it's because a force is being applied to it. So moving on, elasticity. So this is the property of a material body to regain its original condition on the removal of deforming forces. So like I said in the beginning, while explaining with the rubber band, for it to deform, you have to remove this force, right? As long as it has not passed its elastic limit. So for this bead to go back, you can see it going back. It's because I'm reducing the force on it, and when I leave it, it remains the way it was. So that is what this one is just saying. And he said quartz fiber material is considered to be a perfect elastic body. You can search about this quartz fiber material. Is also a good example. All right, moving on. But if you check this material, this PDF we are using for this class, you see a rubber band there. They also used it, as an example. So let's move on, guys. So let's talk about plasticity. This is the property of a material body which do not. So moving on, guys, plasticity. This is the property of a material body which do not show any tendency to recover their original condition on the removal of deforming force. So this is what we spoke about. At this point now, the body or the rubber band has passed its elastic limits. So what this play is actually saying is that okay, so plasticity, this is the property of a material body which do not show any tendency to recover their original condition on the removal of deforming force. So what this is actually saying, just like the example we gave about the rubber band, when it has passed its elastic limits, and when it gets to its plastic, point, such body, might not have the tendency to go back to its original form once it's past its elastic. We will get to that place. You see the pictures of how the stages of how each body undergoes. So putty materials is considered to be a perfectly plastic body. Load, let's talk about load. So it is a combination of external force acting on a body, and its effect is to change the form or the dimension of the body. We've talked about that one. I used my hand as an example, acting upon the rubber band as the body. So any kind of deforming force is known as load. I hope that is understood. We've talked about that. So let's talk about stress. This is the restoring or recovering force per unit area set up inside a body. 2. Stress is due to the property of elasticity that particles tend to regain their original position. This will be the end of today's lesson. Thank you for watching. I hope we've learned a lot. We can take our time and go through the video again, go through the materials, and we can learn more from the materials. So thank you guys for watching. Thank you. Please don't forget to hit the subscribe button and like this video, and also leave a comment behind. Thank you.